Hey there, Mr. Weston here with a video on proving identities. Activity 1.5 and 5.1 had some guidelines for how to prove identities. And in this short video, I want to go over those guidelines and just to make it abundantly clear how we prove identities. In proving identities, we are not solving for a variable. We're not simplifying an expression. We are doing a rigorous mathematical demonstration of showing why two things are equal. Because of this, this is a formal kind of a mathematical argument or discussion. We need to abide by certain guidelines that may seem a little ostentatious, a little overboard, right? I think you know by now I want you to find the way that works for you to solve different questions using correct notation, right? I mean, you can't abuse notation, but, you know, if it's mathematically correct and it makes sense, great. For most other things. For proving identities, though, it's not the answer you're looking for. You're given the answer here. We need to show why this is true. And because this is a very different set of expectations, or a different goal, I should say, our expectations are different. So when we're given an identity like this, now, you know, we may or may not have seen the double angle formula here, but, you know, when we're given this identity, we need to choose a side. And we need to perform a series of steps to show that that side is equal to the other side. And we do this generally by kind of writing that first side, right, kind of as our choice. We generally want to pick the side that has more stuff to it. I've talked about this before. I'll talk about it again, I'm sure. If you would like to, you can say something like left-hand side or right-hand side, right? RHS for right-hand side, LHS for left-hand side. That's kind of beside the point. If you'd like to do that, that's fine. From here on out, all of our work is now vertical, right? Our work should be kind of one step at a time showing this. Our work is not going to be on the left-hand side with equals kind of vertically aligned. Our work is not going to have any arrows. Arrows may make sense in your notes. They may make sense as you're kind of doing homework or whatever, but in proving identity, an arrow means nothing. The only thing that we really have that means equality or kind of direction is the equal sign. So from there, I'm just going to apply the basic identity I know. Tan theta is equal to sine theta over cosine theta. In this case, I'm going to say sine x over cosine x, quantity squared. From there, sure, 1 minus sine squared x over cosine squared x all over 1 plus sine squared x over cosine squared x. And now I don't know exactly where I want to go, but it seems pretty clear. These fractions are kind of messing me up, right? So let's go ahead and actually just add those fractions together. I'm going to do this in 2 steps. It would not be inappropriate for students to do it in 1, but just to make it like abundantly clear what's going on. And now if I actually add these things together, right, I get cosine squared x minus sine squared x all over cosine squared x all over. Notice that as I'm doing this, my fraction bars are kind of different widths. And that's to help me figure out, like, what is a fraction over what, right? This is the fraction over this thing here. So as I go on to the next step, I can say something like cosine squared x minus sine squared x over cosine squared x times cosine squared x over. Eagle eye students will recognize that some of this actually simplifies quite nicely. In fact, that denominator should be very apparent by now that it is 1. And by Pythagorean identity, this is cosine squared x minus sine squared x. Excuse my handwriting, I'm kind of at the bottom here. And this, almost by identity itself, is just cosine 2x. So backing up, sure enough, right? That's what we got from the very top here. Now, this isn't the only way to prove this identity. There's multiple ways, multiple different things you could do. In fact, a lot of students I've seen, again, vertically aligned, said, well, let's just instead multiply top and bottom by cosine squared x here, right? Multiply all of this by cosine squared x over cosine squared x. And sure enough, very, very quickly from here, right, you get cosine squared x minus sine squared x over cosine squared x. Excuse me, minus sine squared x. And this clearly is what's down here, right? So if you didn't like fractions, right, if you kind of wanted to simplify this stuff down quite a bit, you could absolutely do that. That's not the big purpose of this, is that for proving identities, we must start with one side, write an equal sign, our first step, and then all subsequent steps are now vertically aligned, right? And I know many of you are kind of complaining, well, that doesn't make any sense. Like, what? I'm telling you, this is how we prove identities. And this is how I've proved every single identity for all of the work I've had to check and review. Like, this is not something I'm asking of you because, I'm a jerk or, whatever. Like, some other stuff. It's all this way because this is how we prove an identity. So again, just to review, no arrows. I know I have some arrows here, but again, that was kind of sidebar, right? If we just got the black text there, there's no arrows to communicate anything, right? It's all done with the subsequent steps of just one thing or after another. And many of you may be saying, well, that's not enough, right? I need to show more. That's all we have. And so we really need to show one step at a time to show why these things are true. Again, start with one side. Move vertically. If you need to, feel free to take your pencil or your eraser, your ruler. Find the 8.5 by 11 is our size of paper generally. Find the 4 1/4, right? Draw some lines here at 4 1/4, and just kind of right make some vertical lines here. Kind of do your work on one side and the other, one step at a time, right? This is what the expectation is. Focused, first described in activity 1.5.1, but reiterated over and over in my feedback about quizzes, about homework, about all of this. This is how we're supposed to be proving identities. If you do have any questions, comments, concerns, let me know. Talk to you soon.